Good morning. My name is Brian Shipley with Long Building Technologies. Welcome and thank you for tuning in to this week's segment of Long Coffee Breaks. I am pleased to be here and excited to discuss with you saving energy. Today, for the next 15 minutes, we're going to be talking about energy savings. We all intend and strive to save energy, which equates to saving money. And who doesn't like to save money? You need to save it if you want to spend it. I have been fortunate to be in the HVAC industry since 1985 here in the Pacific Northwest. As new energy codes are implemented and technology advances, we find better and more efficient ways to do things, including saving energy. There are many ways to save energy. Today, our topic is pressure independent control valves, the easy path to energy savings. Please feel free to ask any questions at any time using the chat function. We will be able to answer the questions after the feature presentation. We will stay on to provide answers after the coffee break for as long as it takes. Our guest host and subject matter expert today is Ken Duncan with Belimo Americas. Ken, welcome to today's long coffee break.
Hey, good morning, Brian and everybody. Thanks for inviting me. We're going to go ahead and I'm going to switch over and take control here of the screen. All right, there we go. All right. Well, I'd like to thank Brian and everybody at Long Building Technologies for hosting this coffee break session today. Like I said, my name is Ken Duncan. I'm the District Sales Manager for Belimo in the Pacific Northwest. After the presentation is over, we will have some time to answer the questions. And I just want to thank everybody, and especially Long, for inviting me today. Our topic today is to explain how pressure-independent control valves save money on your HVAC projects. There are upfront savings that are realized when using PI valves, but today I'm mainly going to focus on long-term energy savings that can be captured by using pressure-independent valves on projects. This slide shows our pressure-independent product line, which include both mechanical and electronic pressure-independent valves. Most of our pressure-independent valves are two-way valves, but we do have one six-way valve in the middle of the screen that's typically used on radiant beam systems when you utilize both heating and cooling water for a ceiling mounted panel. I'm going to keep going fairly quick here so we can get to the simulator at the end, but this is a picture of our pressure-independent valve offerings. During this 15-minute webinar, it's going to be a quick overview of the pressure-independent valve in general. We normally cover this material in about 4 hours, so today's presentation is truly going to be just an overview of the topic. If you want further information on pressure-independent valves or any of our products, please contact either me or Brian, and we'll be happy to set something up for you. So first of all, we're going to discuss how pressure-independent valves are physically different than pressure-dependent valves. Then we're going to explain how pressure-independent valves save installation costs and money over the life of the building by reducing pumping power. At the end of this PowerPoint presentation, we're going to switch over to a program that simulates a 4-story office building with hot water fan coil units. And I'll explain a little bit more about that simulator when we get to that part of the presentation. So this slide shows a pressure-dependent control valve on the left side and a pressure-independent control valve on the right side. You can see they're both ball valves. The ball valve on the pressure-dependent valve is right here, and the ball valve in the pressure-independent version of the valve is here. Like I said, I'm going to keep moving fairly fast here through this. But when we size a pressure-dependent valve, we have to calculate what we call the CV of the valve. And the CV is the amount of water that the valve will flow with 1 pound of pressure drop across the valve. And we typically size a pressure-dependent control valve to have between 3 and 5 PSI of pressure drop across the valve when it's wide open. If we can keep the pressure constant across this valve, the flow will maintain, it will maintain a constant flow. Well, pressure dependent valves don't have any way to keep the flow or the pressure across this valve constant. Any change in the hydronic system with a pressure dependent valve will change the flow through the valve. Pressure independent valves have a pressure regulator built into them, and that pressure regulator allows the valve to be sized for flow, and we don't have to worry about a CV for the valve. This dynamic regulator is what makes this mechanical pressure independent valve ensure that we always have the same amount of pressure across the ball valve. Now, this cutaway shows that our pressure independent valve is basically a dynamic pressure regulator in this area and a pressure dependent control valve here. Now, as long as I can keep the pressure constant, the differential pressure across this ball valve constant, the flow coming out of the valve is going to be constant. And that's the whole purpose of this regulator section of our mechanical pressure independent control valve. As long as I can keep the pressure differential constant, the flow is always going to be the same coming out of the valve. So the other type of pressure independent valve we have is an electronic pressure independent valve. And this valve shows a comparison of an air and water side pressure independent system. The upper part is a pressure independent VAV box, which you probably are all familiar with. The flow ring or the flow pickup comes back to a controller, and the controller calculates the CFM that is flowing through the box. And then the damper is automatically modulated to maintain the airflow set point. Our electronic pressure independent valve works in the same manner. We have an ultrasonic flow meter that's giving a signal back to a controller, which is integral to our valve actuator. And the actuator looks at the set point from the DDC system, compares it to the flow meter, and adjusts the control valve to maintain set point. That's any change of system pressure or system flow would be picked up by the flow meter, and then the actuator would respond to that change. So there are several reasons why PI valves are better to use than pressure dependent valves. So one reason is the system pump, the pump that's pumping the water around your building, can be operated at a much slower speed because the differential pressure within the system can be lower when you're utilizing PI valves. Our pressure independent valves only require 5 PSI of differential across the valve to operate properly. That's much lower than what most pressure dependent valves will require. No balancing devices are needed within the system. You don't need to buy a Griswold or a Nexus or an Armstrong balancing valve to put in the system with pressure independent valves, because they are a flow regulating device along with being a control valve. So since the differential pressure across each valve in the system is lower, the overall system pressure will be lower in the hydronic system, and that will reduce your pumping costs. The system is also self-balancing. So whenever anything in the system makes a change, the pressure independent control valve has the ability to adjust itself and adjust the flow at every valve. That is like having a constant tab water balancer on staff balancing your building and keeping it at optimum performance. And it also prevents overflowing water at the coils that are nearest to the pumps. Typically, the differential pressure in a piping system is higher, closer to the pump, and at the end of the building, you have lower differential. So the valves that are nearest to the pump will overflow on a regular basis. So this is what I wanted to get to. This is our hydronic simulator, and it can be downloaded from our website. And in this situation, it's a 4-story building with 5 heating coils or fan coil units on each floor. Each one of the fan coils is designed to have a maximum flow rate of 1/2 gallon a minute. We have a mixture of pressure dependent and pressure independent valves in the system. And that is to show how the PI valves automatically adjust for system pressures while the pressure dependent valves can't do it. So I'm going to walk you through what I'm going to do in the simulator just so you know what's going to happen. So the first step in completing our drive-by water balance is that we're going to open up all the valves in the system. So all the control valves and all the circuit setters, we're going to open them up and get a full flowing system.
Hey,
We're going to go ahead.
Your simulator's not showing.
Okay, we're going to bring it up in just a second
Oh,
here.
I'm sorry.
No, that's all right. So what we're going to do is we're going to record the pumping cost and our head pressure with the system wide open. Then we're going to balance the system and record those two values. And then I'm going to slow the pumps down and show you what happens when we reduce the system pressure and how the pressure independent valves are able to compensate for that. So let me go ahead and fire up the simulator here now. I've just got to change, sorry, I just got to change screens here. All right, so everybody should have the Brian, we have the simulator up on the screen now, right?
Yep, looks good.
Okay.
Quick question. How do you identify the pressure independent valves versus the other valves on your screen there?
Yep. So on this screen, we have 5 pressure independent. These are the mechanical pressure independent valves. There's one here. There's one here. There are 2 of them on the second floor, and then there's one of them down on the first floor.
Okay.
These indicate the circuit setters. So if you notice, these have manual balancing valves, and you can manually balance the system by clicking on these icons here. As you notice, there is no manual balancing valve on our PI valves because we don't need them. So we have 2 buttons in here where I can open up all the valves in the entire system and record my pumping cost and my head pressure with the system wide open. And then I can magically balance the entire system with a push of a button. So this is typically what a water balancer would do. They'd open up the system and then they would start balancing it. But rather than spending hours running between the valves, I'm just going to go ahead and balance the system with this button. So with the building balanced so that all the valves are green, if these numbers are green, that means we're within 2% of the desired flow rate through the unit. So as a baseline, we're running the building at 118% pumping costs, and we're running just under 30 PSI of head pressure on the pumps. So that's with the system wide open, and we're balanced. And you can see from doing this in the past, I know that this fan coil unit on second floor is going to be my worst case fan coil. So when the plumber or the fitter piped this unit in, there's something unique about this line here, and this unit struggles to get water. But what I'm going to do is, this is our baseline of 118%, 30 PSI. Since our valves are rated down to 5 PSI differential, I'm going to go ahead and slow the pump down until I get this problem unit out here at the end right down to 5 PSI. And we're going to see how much I can slow the pumps down and still maintain 5 PSI at this unit. So I've got 4.97 PSI. This valve has opened up a little bit. I'm still flowing my design flow, but my pumping cost has dropped from 118% to 102%. So just by lowering my pump pressure just a little bit, I've done a 16% reduction in my energy costs on my pumping costs by being able to lower the pressure down to 5 PSI. Now, you can see the pressure dependent valves are starting to lose flow, and I'm not achieving my design flow set point because I don't have enough pressure in the system. But the pressure, every one of the pressure independent valves is able to open up that regulator section and allow more water to flow through the valve. And they're still maintaining my design flow rate. So I'm going to get more aggressive in my energy savings here, and I'm going to start slowing the pump down until this worst case valve starts to not operate properly and not maintain my half a gallon a minute. And you can see I'm bringing the pump speed down pretty dramatically right now. I've got just over 3.5 PSI at that valve, and it's still maintaining flow. I'm at 3.1 PSI and I'm still maintaining 100% flow. Okay, so I dropped below 3 PSI, and now the pressure regulator doesn't have any more movement, and it's not able to open up and allow more water to flow through it. However, so I brought the pump back up to 14.5 PSI. Every one of my pressure independent valves is still flowing design flow, while my pressure dependent valves are all about 25% short on flow. So my pumping cost has come down from 102% when we had the balance condition to 43%. I've reduced my pumping cost by 75% just by bringing my system pressure down and ensuring that my worst case valve has enough pressure to operate properly. I brought my pump head pressure down from 30 PSI, which is what it was in our balanced condition after pushing the balance button. And I'm running it at just under 15 PSI, and every one of the pressure independent valves in the building is still able to control flow, where the pressure dependent valves aren't able to do that. Like I said, our published minimum pressure rating is 5 PSI. However, the valves will operate below that. So it just depends on how you want to operate your building and how much time you want to spend performing a water balance to find the optimum balance point within your building. And Brian, that's pretty much the quick overview of the hydronic simulator and just a quick overview of pressure independent valves.
That's awesome, Ken. Thank you very much. So we're going to cut it short. We're going to take questions off the air, of course, because we're time to turn it off. But I want to thank everybody for joining this week's coffee break. This video will be shared via Long's YouTube channel. Please reach out to myself or Ken if you got any questions. And next week's topic for Long Coffee Break is Linnell S2 Blue Diamond Mobile Credentialing. Thank you.
Thanks, everybody.